In this video, we will be learning on vertex cover. Firstly, let us understand what is vertex cover problem. In the mathematical discipline of graph theory, a vertex cover, sometimes node cover, of a graph is a subset of vertices which covers every edge. In other words, a vertex cover for a graph G is a set of vertices incident to every edge in graph G. For an example, given a undirected graph, we try to find the vertex cover with minimum size. In the graph, there are 7 vertices and 7 edges, so let's start to find the vertex cover. In the first step, we choose the vertices 1 and 2, so we can see that it is covering only 4 edges out of 7, therefore, it is not the vertex cover problem. Now, we have chosen the vertices 1, 2 and 6, so we can see that 6 edges out of 7 are covered by these vertices, therefore, this is also not the vertex cover problem. Again, we continue choosing more vertices to cover all the edges, this time, we chose vertices 1, 2, 6 and 7, now we can see that all the edges are covered but, the vertex cover size is 4. Though, all the edges are covered but our finding is to have the minimum vertex cover size, therefore, we reduced the vertex cover size by choosing only 3 vertices such as 1, 5 and 3, which will cover all 7 edges. Hence, we can conclude that, the minimum vertex cover size for this graph is 3 and the vertices are 1, 5 and 3. For that, let's start solving it using Blueqat in Google Colab. Firstly, we need to install Blueqat in Google Colab and run it. Blueqat is successfully installed. Then, import libraries for Blueqat like NumPy and Blueqat optimization as shown here. Firstly, let's define the edges of undirected graph to find vertex cover with minimum size. Once we are done with the installation of Blueqat in the Google Colab, we can define edges of the undirected graph like this. These are the edges joining from one vertices to another. For an example, edges 1, 5 means vertex connected to 0 are edges 1 and 5. Edges 2, 5 means vertex connected to 1 are 2 and 5. Similarly, others edges represent how each vertex are connected with one another. Now we prepare some functions. We will create a kubo. For that we have the variable a and b in which the value assigned to a is greater than the value of b. We will define the getKubo function which will create the kubo of a given edges. It will process the looping control within the length of edges. And if the condition is true, it will execute this statement. If not, it will execute this statement. And, finally it will return the kubo queue. After this, run the code. We have another function that is showAnswer which will print the result of list x, that is the list of integer number of 0 and 1. 0 represent the subset is not selected whereas, 1 represents the subset is selected. After this, it will print those selected groups which fulfill this condition. Now, let's see output. We will try for 5 times and print the output of each time. Every function will be called for their respective tasks. From the clue, we are able to identify the number of selected vertices of the undirected graph. In the output, it will show the result which is the integer numbers of 0 and 1 generated by the getKubo function. Each time, the result is printed, selected vertices will be same or different. From the result, we can see that how many vertices has been selected for each times and therefore, we can conclude that, the minimum vertex cover of the undirected graph is 5 that will cover all the edges. Thank you for watching this video.